The PowerPoints are there too. You want to study the PowerPoints. Unit 1 test will be from chapters 1 to 3. This worksheet and the other one in there are from chapters 1 to 3. So what we are discussing are going to be in the test. Okay, so we are going to start with question number 21. We are told to do a box. First of all, we want to do a box and whisker plot, or box plot, whatever you call it, of the data in number 21. And because you are allowed to use your calculator in everything you do, as I told you before, so you actually want to put this data, raw data, in your calculator. I still need the data in my L1, so I'm going to use my L2. So I put my calculator on the screen. So I want to put the data in my L2. All right, so the first number is in the data is 33, enter. So I enter the data 39, 41, 31 again, 36, 44, 22, 40, 46, 33, 41, 37, 33, 26. Okay, so I am told to draw a box and whisker plot. I want you to see the other questions too. I want us to see that we are also told to find the mean, well, find the sample standard deviation and variance. All right, so the first thing I want to do is to draw a one variable stats of this data that I already put in my L1. And by the way, if I'm told to find the mode like we were told to do the other day, I can sort this data in ascending order and find the number that occurs most. The mode is always the number that occurs most. So I can set out now to sort this data in ascending order. So I'm going to go to start, and sort ascending is number 2. So I'll take number 2 and make sure I tell my calculator that the data I want to sort is L2. It said it's done, so I'm going to start edit. So this data is sorted in ascending order. All right, so because I'm actually told to do a stem and leaf plot, so I might want to start answering this question immediately. So do a stem and leaf plot. So I can quickly go to the board and start doing a stem and leaf plot. All right, so I get a pen. I'm getting my pen now, so I can do a stem and leaf plot. So I'm going to do the stem, one digit stem, and leaf, one digit leaf. I want to do one digit stem and one digit leaf. So I'm going to take this out. Go back to my pen. Draw. Okay. So I'm drawing. So I'm going to do one digit plot and one digit stem. So I have stem here, and the other one is plot. Stem and leaf. All right, this needs to get out of here. Okay, so my stem and leaf. Okay, the first digit in my calculator, I'm going to be looking at the data is sorted in ascending order. So the first number there is 3. So I'm going to start with 0, 3, and the next number is 4. So 0, 4, and the next number is 22. So I'm going to 2, 22. The next number is 26. I'm going to write 26 here. The next number is 31. So 31. So I'm doing a stem and leaf plot, answering one of the questions. Okay. So that is 22, 26, 31. And the next number is 33. Another number is 33. So I have 33 again. So there are 2 33s. Okay, so I'm going to check to make sure that I take advantage of all the numbers. So I did 2 33s and 36, 37, 39. So 36, 37, and 39. Okay, so the next number is 40. So I put 4 here. So to make sure that all the numbers are there, I want to arrow to the last digit. So I have 2 41s, 2 41s, 1, 1, 6. And so I can actually see that when I do the stem and leaf plot, it's easy to eyeball everything. So now this data is organized somehow in stem and leaf plot. So when I eyeball the stem and leaf plot, it is easier to find the minimum number and the maximum number. In fact, I can be told to find the range now. By the way, the range is the maximum minus minimum. So I can already see that the maximum number is 46 and the minimum number is 3. Therefore, the range is 46 minus 3. 46 minus 3 is 43. So when you arrange a data in stem and leaf plots, when you eyeball it, it's easier to manage. The data is easier to read, much easier than the raw data given to me. So the first thing I did is put the data in L2, sort the data in ascending order, and then construct a stem and leaf plot. Also, I can be told to, from my stem and leaf plots, actually show if the data is skewed right or skewed left. So when I eyeball this data, I can actually superimpose a density curve on it. So I can see from my density curve that this data is actually skewed left a little bit. That shows me, because if a data is skewed left, and the data is skewed left, it means that the mean is less than the median. So this now tells me that the mean could be less than the median, and I will confirm that. If the data is skewed left like this is, then the mean is going to be less than the median if you eyeball the stem and leaf plot. Also, when a data is skewed right, the mean is greater than the median. If the data has a bell shape, we know that the mean is equal to the median. So quickly, I want to check, actually, is the mean greater than the median or less than the median? Let me check that. I'll do a one variable start. like we did the other day. And one variable start of the data in my L2. And then I don't have frequency because it's still a raw data. So I will leave the frequency space alone, and I'm going to calculate. What I'm checking now is the value of the mean and the value of the median. So the mean is approximately 31 to the nearest whole number. So that's the mean. So I'm going to go down and check the median. The median is 34.5. Therefore, the mean and the median are not equal. Median is greater than the mean. And that is why the data is skewed left. The data is skewed left because the mean is greater than the median. All right. This question also told me to find the sample standard deviation. So this is the sample standard deviation, S of x. Everything belonging to a sample is called sample characteristic. And every sample characteristic is called a statistic. Sample characteristics are statistic. Population characteristics are called parameter. Okay, so the approximate sample standard deviation is 13. And if I'm told to find the variance, then I will square the standard deviation. Find the square of the standard deviation. So let me find the variance. So many ways I can find the variance. I can quickly just copy this down and square it, or alternatively go to VARS, statistic. If I go to VARS statistic, every statistics I just did is there. And I'm looking for sample standard deviation right now. So if I click that, it gives me the value with all the decimal points. So I don't have to copy it. There's nothing that your calculator cannot do. All right, so I used VARS statistics to find the sample statistics I just did. Now I'm going to find the variance. All I have to do is square the sample standard deviation. And when I square it, I get the variance. So the sample variance is approximately 174. The sample statistics is approximately 13. Suppose I'm told to leave my answer to the nearest 3 decimal points. I got to be careful. You have to read the question very well. My lab maths will sometimes ask you to leave your answer to the nearest 1,000. That's 3 decimal points, or to the nearest 100, 2 decimal points, to the nearest 10th. So you have to be careful when you're reading the question. All right, so to the nearest 1,000, the sample standard deviation is 13.178. To the nearest 1,000, the sample variance is 173.670. Okay, so it's actually easy when you are using your calculator. So we have already done the stem and leaf plots. We found the sample variance and sample standard deviation. Very easy, just because we are using our calculator. Okay, another thing we are told to do is a box and whisker plot. Do a box and whisker plot. So I'm going to clear this. Hopefully this is not cleaning very well, but maybe I have to use my whiteboard. Let me go to my whiteboard, and that can help. So I'm going to clean this. I'm pulling my whiteboard up because I want to use it sometimes. Okay, so I want to draw a box plot of the data that I have. So I want to draw a box plot of that. Before I draw a box plot, I have to go to my calculator again. So I need to pull up my calculator again. Where is my calculator hiding? All right, so I'm going to actually pull my calculator up again. It is hiding somewhere. All right, so I'm going to pull it up again. And the data is still in my L2. So I am going to do a one variable start of that data in L2 again, because I need the 5 numbers somewhere. Okay, so I'm going to calc on one variable start of the data in L2. I'm going to calculate. All right, so I'm going to arrow down. So when I arrow down, I see the 5 number summary. I like to take a picture because when I touch the calculator, it's going to disappear. So I have to take a picture of it. So now I see the 5 number summary is always going to be in my one variable start. Number 1 of 5 number summary is the minimum number, which is 3. The second one is Q1, which is the first quartile. Number 3 is the median or the second quartile. Number 4 is the third quartile. Number 5 is the maximum number. So I actually have them here. So I'm going to quickly write them on my whiteboard. So 5 number summary. 5 number. Oh, this is big. I'm going to make it smaller. Summary from my one variable start. Okay, number 1, I got 3 minimum number. So I can quickly go ahead and draw a box plot. I'm going to quickly draw a box plot. We can call it a box and whisker plot sometimes. Oh, this is not drawn to scale. So this is my box plot. And I will start putting in the numbers. The minimum number is always at the left tail. Therefore, the minimum number is 3. The first quartile is at the left box. That's 26. The median is, I'm going to put the median here. The median is 34.5. The median. And the third quartile is at the right end of the box. Therefore, the third quartile is 40. And the maximum number is 46. So if I know how to do one variable start with my calculator, I can find the 5 number summary of any data given to me. And then I can just draw a box plot and put that in there. And so this is my box plot. I'm told to draw a box plot of the data. Okay, so that is the box plot of my data. So see, I have already done a stem and leaf plot. It's an example of quantitative variable. I hope you, when you read your PowerPoint, you see that quantitative variables can be average. Averaging makes sense. Averaging makes sense in quantitative variables. And the kinds of graph you can draw are stem and leaf plot, box plot, and histogram. All right. So I found the 5 number summary from my one variable start. Then I drew a box plot. So the next thing now is for me to So I'm going to find what is called the interquartile range. So what is the interquartile range? Anytime I'm told to find the interquartile range, I must have the quartiles, all the quartiles, Q1, Q2, Q3. So now I'm told to find the interquartile range. So the interquartile range, interquartile range, in short form is called IQR. IQR, anytime you're told to find the interquartile range, it's called IQR. It's equal to the third quartile minus the first quartile. Third quartile minus first quartile. And the third quartile in this is 40. And the first quartile is 26. 40 minus 26 is 14. Therefore, interquartile range is 14. Therefore, IQR is 14. IQR is equal to 14. The interquartile range of this data is 14. And by the way, you can use the interquartile range to calculate an outlier to see if there's an outlier in the data. An outlier is caused by maybe a variable that is too high or too low. Some of them could be called a confounding variable or any other name that you have to, you can put it in. So now we calculated interquartile range. We have already done stem and leaf plots. We have drawn a box plot. We found the standard deviation. And we also found the variance. Standard deviation squared is variance. We found the 5-number summary. And so we also know that the 3 quartiles. If you know the 3 quartiles, you can find the interquartile range. Okay, so now suppose I am told to draw a histogram of this data. I can do it by calculator. And by the way, let me first of all make, by the way, let's go to, let's draw a histogram of the data in my L1. So I will do second start plot. And I will select plot 1. And I'm going to select histogram. Histogram is number, arrow down, go to number 3, that's histogram. And my data is not in L1, I have to be careful. My data is in L2, gotta be careful. That data in L2 is not organized, it's not in group. So it is not a group data. And if you don't have a group data, you do not have frequency. So I'm going to actually zoom 9. Let me zoom. Anytime I try to zoom 9 and this argument comes out, you just have to second quit and then zoom 9 on the main screen. Zoom 9 on the main screen. So I have drawn a histogram of this data. Again, if I try to eyeball this histogram, you will see that the histogram is skewed left. If I draw a density curve on this histogram, it is skewed left. Watch what I'm going to do. Let me draw a density curve that suits this histogram. So that density curve is skewed left. In other words, the mean X bar is less than the median in any density curve. If the mean is less than the median, we call it skewed left distribution. Skewed left. skewed left. And skewed left is the same as negatively skewed. Just in case you see negatively skewed, negatively skewed. Okay, if a data is normally distributed or bell-shaped, then the mean is equal to the median. That's a crooked bell shape. Forgive me for that. If a data is bell-shaped, so let's say this data is bell-shaped. Bell-shaped. In other words, if you superimpose a density curve on a histogram and it is bell-shaped, then it's an indication that the mean X bar is equal to the median Q2. Alternatively, if you superimpose a density curve on a histogram and the data is skewed right, then the mean X bar is greater than the median. The mode is never changed with outliers. Outlier doesn't really affect the mode that way. So here we shall say that this, if data is skewed right, we will say that this data is positively skewed. Skewed right. Skewed right. Skewed right is the same as positively skewed. Skewed right or positively skewed. Positively skewed. Okay. All right. So these things I have drawn here are called density curves. So you will be seeing density curves in your practice test. And they'll be talking about skewness. And what causes skewness? A very large data in the midst of what you're doing causes positive skewness. And a very small data in any given data is causes a negative skewness or negatively skewed data. If a data is bell-shaped, then almost all of them have the standard deviation will not be too much. The deviation from the mean of each of them will not be large. So we talked about density curves. And these are your PowerPoints. When you open your PowerPoints, chapters 2 and 3, you will see density curves, histogram. Okay. And histogram can be skewed left, skewed right, or bell-shaped. Okay. And then I'm going to get a big data, or I can actually try to organize this data as a group data. So I can try to group this data. It's not a lot. So now I'm going to try and group the data and make a grouped data out of it. So I'm talking about the data in my L2. What do I mean by grouping the data? I am not going to have intervals in this one. I just have to group. So here I have, it may not be classes. So I'm just going to start, or I can just make it in classes. So I already know the smallest number. So class, frequency. Okay. And the smallest number is between 0 and, so I'm going to say between 0 and 9. How many of them I will find out? 0 and 9. between 10 and 20 and 19, between 20 and 29, between 30 and 39, between 40 and 49. So I'm going to, let's put this in, we are trying to group this data. So I'm going to say grouped data. We're trying to group that data we had. Grouped data. So anytime I'm told to group a data, it's another way of arranging the data you have, so that organizing, so that it will be easier to read and interpret. Okay, so I'm going to go back to my start, edit, and this time I am grouping the data in L2. So I am going to count all the numbers in from 0 to 9. I can actually eyeball this data and see. Let me see. The smallest number is 3. So there are only 2 numbers that are between 0 and 9. So I'll write 2 here. So the frequency is 2. The number of occurrence is 2. So now I'm going to count all the numbers between 10 and 19. And if I look up there, there is none. So I'll put 0 there. There is no number between 10 and 19. And I'm going to count the numbers between 20 and 29. And actually, there are only 2 of them, 22 and 26. So 2. I'm going to count the numbers between 30 and 39. So I'm going to arrow down so that I can find them. I have 31, 33, 33. So I have found 3 already. I'm looking at my data in ascending order. Number 4 is 36. Number 5 is 37. Number 6 is 38. So there are 6 of them. Therefore, the frequency of 30 to 39 is 6. There are 6 of them that are between 30 and 39. So the next thing is group the data 40 to 49. There are how many counts? 4 of them. So there are 4 numbers between. There are 4 numbers between. All right, so now I'm done grouping. So what I have, this table I have is called a frequency distribution. So I just made a frequency distribution, just like that. So I made a frequency distribution out of the data I have. So see, we have already, having a calculator makes my work easier. So right now we have already done a stem and leaf plot. We have done a box plot. We found the 5 number summary. We found the standard deviation and variance. And now I did a frequency distribution of the data. I grouped the data. So the next thing we are going to do is the relative frequency distribution. So I'm going to add a column